Today we're flying a drone with a laser scanner on it. It's a Lidar system. We're at Catawba Sustainability Center. In this case, we're actually mapping the upland area where they just did some agroforestry plantings at Catawba. And the laser scanner we have on here will give us really very high resolution topographic information. So we'll be able to map this entire field, and we're going to map it over time. So the laser scanner also, it maps the ground, but it also maps the trees and the shrubs. So we'll be able to, over time, map the growth of the trees and the leaf area, the biomass, things like that in the tree system they planted here. So we'll be flying it at least 2 more times, maybe even 3 across the next year.
Going into manual mode to test the tree line along the stream. Tell them we're approaching 15, which will be the outside boundary.
Approaching waypoint 15, which is the outside boundary.
The technology on here is actually pretty new, that we could get a big enough drone and a small enough LiDAR system weight-wise to be able to put it on a drone. We fly it, the ground as it is, and you get a really high resolution topographic map. And that helps you plan where maybe you should plant. If you're trying to plant on the contour like they have done here, it gives you really high resolution topography to define that contour. And they've also used the elevation that we've given them to decide where to put certain plants. So down in the floodplain, some trees do better with wet feet, so that means they're in the water a lot or the ground's saturated. So depending on the elevation, so the farmer could do the same thing where maybe he doesn't plant a certain row crop in a very low area because he knows it's probably going to fail or not do well because corn doesn't like to be too wet. So I think that the mapping, very high resolution mapping, can help with kind of planning on what to plant where. But then also over time, I think this technology, we can identify trees and shrub types. I think you could even use it to find weeds. So you could fly over a field and be able to post-process the data and find where the weeds are, and then maybe come out later with a different drone or the same drone with a tank on it and spray it with herbicides.
When the data comes back to Virginia Tech from the drone, we first have to georeference it. So we will connect it to the GPS and the base station so that we really have confidence in the resolution of data that we're getting here, which is really on the order of inches and centimeters. So some of the things that we first do, we first georeference the point cloud, and then we'll find to do a lot of other sorts of steps. We want to classify the point cloud so that we might be able to pick out, for example, trees from the bare earth. And thus we'd be able to really understand the topography of the location. And this is important if we're talking about design of where to do a new building or a new planting, to the kinds of details like how is this watershed here, what's the slope, how steep is this. All of these measurements, which we use for biology and for hydrology, water modeling, are really important. And so here you can see the swales that they dug in for this new planting at Catawba, and we really do have data down to the level of inches, and we're able to see actually where these plantings were put in. So the level of detail is really important, although of course what the challenge that's simultaneous with that is, how do we handle these huge data sets? What we're looking at here is about 8 million points. Here's the road going down past Catawba. We use a lot of mathematics and other kinds of tools to subsample the data. Right? So even though the drone collected 38 million of these laser points, we're only really showing 8 at a time right now. But we're still structure of the creek, the density of the planting along the hillside, the slope of the hillside. And so being able to capture and measure the 3D structure with high degree of accuracy is really important, whether it's for science or for design.